We bring in like when I finish okay.
Okay, go.
Okay, go. Windows. Okay.
Elke plek waar je nou je dak kan beginnen, zo daar, hoe je komt ja.
Kingdom halls are truly special places of worship for Jehovah's Witnesses. Thousands of these buildings have sprung up over the last 2 decades. In urban centers, beautiful structures are often completed in just a few days. But for many witnesses, a kingdom hall of their own is just a dream. For what reasons? Some congregations simply do not have qualified builders. Funds are usually limited if there are few breadwinners. Good quality building materials are not always readily available, and building methods could be restrictive. Under these circumstances, construction is often painfully slow. 4 such congregations in the Kwakwa region of South Africa approached a regional building committee in Johannesburg for assistance. The Makwani, Makong, Tseki and Tseseng congregations each needed a kingdom hall with seating for about 100 people. So, is it possible for congregations in regions like this to have a kingdom hall? This is the challenge facing many regional committees. How did the regional building committee from Johannesburg respond? They devised a method to overcome all these obstacles. Firstly, they used a simple floor plan with outside toilet facilities. Secondly, Walls were constructed with dry stacked interlocking blocks made by the congregation from local soil and cement. Thirdly, a fiber cement roofing system that looks attractive and requires no ceiling yet provides proper insulation was used. Fourthly, all 4 halls were built in just 2 consecutive long weekends by volunteer workers from Johannesburg. The foundations are typical of any small structure. Concrete footings, brick foundation walls, well-compacted backfill, and a concrete floor slab. The toilets are built at this time so that toilet facilities would be available during the build weekends. A scientifically designed version of the normal septic tank with soakaway is used. The floor slabs are worked smooth with a power float so that a screed is not necessary. Each congregation manufactures its own bricks. Interlocking blocks of a unique design are produced right there on site. Suitable soil for brick making is found 500 millimeters below the surface and containing a small proportion of clay is dug from the site. Topsoil cannot be used unless the clay content is correct. The soil should carefully be sieved through a strainer and mixed with sand and cement. Although only 5% cement is suggested, it was felt that it would be wiser to increase this to 10%. A very small amount of water is needed to moisten the mixture. Bricks are tested with a penetrometer. The machine used to manufacture the wall blocks was designed in India. The newly made bricks are carefully stacked on the floor slab and allowed to cure. Up to 1,000 blocks can be produced in one day. Bricks are covered with PVC sheets and moistened for 7 days. 21 days curing is allowed. Both full blocks and half blocks are manufactured, the latter being essential to maintain the bond. Damp cores needs to be fitted here. When using dry stacked interlocking blocks, great accuracy is required. Since there is no mortar bed or joints, there is no compensation for errors, either in level or in wall dimensions. The corners need to be erected first. The first course of blocks thus becomes the foundation for accuracy and stability on which the whole structure rests. The posts, which also function as profiles, have to be plumbed up so that the first course can be laid, using normal bricklayer's lines and corner blocks. Accuracy is essential, and the last block in the course should fit tightly without undue force. To improve the stability of the long walls, unsupported by any cross walls, it was decided to put 50mm square steel tubing into the walls at regular intervals of 1,8 meters. The design of the block allows for these posts, since the half blocks can be fitted without blocks having to be fed down the post from the top. Non-screed door frames are used. The whole of the first course must be laid out in full before any attempt to erect door frames is made. Each wall must have a full number of blocks without cutting, as the bond of each successive course depends on this. Dimensions and diagonals must be checked at this time, and only then can the door frames be situated. Blocks are removed at the appropriate place and the frame plumbed up and stayed. Frames are built in and river sand mortar packed in behind the frames. Although block laying now basically becomes an unskilled operation, care and accuracy are required. A build-up of sand or small stones on the bed of each course can lift the blocks and make a course run out of level. Careful brushing of each block is essential. Note that each block has an arrow on it, and each block in a course should have the arrow pointing in the same direction. The direction of the arrow is alternated every course to compensate for slight variances in order to keep walls at 90 degrees. Concrete lintels are used only above door frames. Window frames are installed when the appropriate level is reached. Special windows with a square tube welded on the outside of the frame can be used. Already purchased standard steel windows can also be used. The advantage of the windows with the steel surround is that they fit neatly into the recesses in the end of the blocks. To provide additional stability, the square holes through each block can be filled with cement slurry. Holes are filled to 1,3 meter, then marked and filled when block work is complete. Hereby, pillars are formed within the dry stack walls. On these buildings, this was also done to provide a base for steel bolts that were bedded in at the top of the wall in order to secure the wall plate. The remainder of the holes may be filled as block laying progresses, but avoid the over-compacting of slush. In buildings like this, 28 courses are required to reach the full wall height. Once again, it must be stressed that dry stacked interlocking block walls must be treated with care. Without mortar holding the blocks, there is a degree of instability when the walls are at full height. Wall plate height is reached in just 4 hours. With the bolts bedded into the top courses, the wall plate is drilled and installed. For additional stability, wall plates are fitted to all the walls, not just to the walls on which the trusses are to bear. With the wall plates installed, the increased stability of the walls is quite remarkable. This forms a ring beam effect. The fiber cement roofing system adopted for these halls requires trusses at 1,8 meter centers. This adds to the economy of the roof system, as no purlins are required. Each molded tile spans from truss to truss and is fixed directly to the rafters. The trusses are secured to the wall plate by nails, as well as the use of wires or ties. No exposed fixings are used. This is a leak-proof system. Fiber cement sheeting with metal jointing strips is used to close up the eaves above the walls, as well as for the gable ends. Roof tiling is started at the eaves level. The roof tiles are also sprayed to provide a splash of color in the grey environment. Once the first layer is fitted, it is secured to each rafter with a drive screw and washers. Sheeting continues upwards, layer by layer. Each tile unit is molded to resemble a row of normal roofing tiles. It has a deeply dished roll, like a gutter, that helps to prevent water penetration at the back and provides support and cohesion to the next row of tiles. Where the tiles overlap, a small cutout must be made, notching the tile to ensure a tight fit. A quicker system of notching each tile while still on the ground was devised, as this can be time-consuming if done by a worker on the roof. The ridge tile is bedded in cement and fixed. A special ridge board is required that spans across the apex of the trusses to carry the ridge. This detail requires some care, as both height and position are critical. The walls of the halls were brush plastered inside and out. This work need not wait for the roof to be complete, but it is best left until the wall plate has been fitted and the building is stabilized. For these projects, spray painting was used for the outside, which requires careful masking. Internal walls were painted with brush and roller. Considerable time and money will be saved in future as we plan to use color-based plaster. The product is called Kapri. The doors are hung while final finishings are done. Carpets are laid. Curtain rails are installed and the curtains hung. The year text, Kingdom Hall and meeting time sign, contribution boxes and notice board are installed. Finally, the chairs are dusted and set out in rows. The financial obstacle in Kwakwa was also addressed. The local brothers donated all they could and thereafter obtained a small loan from the Society's Kingdom Hall Fund. What was the price tag? Only $6,000 for each Kingdom Hall. However, this by no means detracts from the standard and quality of the building. It is a dignified place of worship. It is hoped that these building methods will prove useful in other areas with similar problems, as this system can also be improvised to address even poorer conditions. So, the challenge was duly met. Jehovah's awesome power brought sure success. All 4 halls were built in April and dedicated to the Almighty Creator on the weekend of May the 23rd, 1998. The combined attendance was over 600. The joy the brothers felt could clearly be seen on their happy faces. At last, each congregation has its own Kingdom Hall. Indeed, the brothers in Kwakwa had benefited greatly from the generous spirit of the volunteer workers from Johannesburg. This fine spirit had been built up during the construction of many quickly built projects in their own urban areas. Many were the expressions of gratitude to all who had helped. See, Isaiah 54 verse 2 has been fulfilled in Kwakwa. Jehovah's people needed to make their tents more spacious by stretching out the tent cloths, lengthening their tent cords, and making their tent pins strong.